Welcome to our webinar tonight, everyone. Pleased that you decided to join us. This is Josh White. I lead the producer education team here at National Cattlemen's Beef Association. Hopefully you're at the right place. This is making the best use of current genetic selection tools. We have a large number of participants tonight, so your line is muted. You'll only hear us. You won't be able to talk back to us, but feel free to use the question or chat boxes on your screen to send in any questions throughout the presentations, and we'll get to those at the very end. We're also recording the webinar, so if you have any technical difficulties or if you have to leave the webinar early for any reason, we will be sending out a link to the webinar to all registered attendees, most likely tomorrow if all the technology works well. On the webinar tonight, we have two great speakers, Dr. Alison Van Eenennaam, Extension Genetics Specialist at UC Davis, and Dr. Matt Spangler, Professor and Beef Genetics Specialist at the University of Nebraska in Lincoln. And we're going to kick things off with Dr. Spangler tonight. Hand those controls over to you.
Okay, well, thank you, Josh. I'll get this brought up here. All right. Hopefully everyone can see that.
Looks great.
I appreciate the thank you. I appreciate the opportunity to visit with the group tonight, and particularly share my time with a close colleague. I wanted to visit just briefly about really the need to utilize the science that we have, and then spend just a little bit of time talking about emerging selection tools, more to create awareness that there are additional tools in the toolbox. So if we think about what's been available to the U.S. beef industry for a considerable amount of time, really we should focus selection decisions using, or focus decisions on the use of EPD and economic selection indices. There's absolutely no question they're the best tools to generate response, either in specific traits as it might relate to the use of EPDs, or in commercial level net profit as it relates to the use of economic selection indices. And I think that's an important thing for people to understand, is that economic selection indices, and we'll visit about those a little bit more later on, are really designed to be used to increase net profit at the commercial level through genetic selection. And I think all too often those tools are misunderstood, but they're exceptionally effective. These tools are refined over time as science and technology advance. So you can think back to 18 to 24 months ago when there were large changes in the way genomic information was included into EPDs. That's a refinement to the total genetic evaluation system. And we're going to continue to see those kinds of refinements over time, making EPDs and economic indices more accurate. And I think that's a positive thing, and those changes should be welcome. Additional EPD are added when data become available, and there's either a need or a desire to change a given trait. So there are things that are impactful to commercial cattle enterprises or to the beef industry at large, where we simply don't have data available to use to generate EPD. But generally, when there's enough need demonstrated, enough desire demonstrated, then there become these large efforts in data collection, and we see prototype EPDs emerge. And so I would say that traits that are relatively easy to collect and that are of interest to a broad geographical region have EPD in most genetic evaluations, or in other words, most breed organizations have an EPD for those traits. So think about things like weaning weight, post-weaning gain, relatively easy to collect carcass metrics like ribeye area, intermuscular fat. Of course, what's the driver for EPDs of those are really the ultrasound proxies, things like calving ease. Those are items that are relatively easy to collect, and regardless of where your commercial enterprise exists in the U.S., those are traits that probably have some degree of importance to your breeding objective. Emerging traits generally focus on complexes, so suites of traits that are unique or novel in some way. So they may represent things that are relatively expensive to measure or difficult to measure. Those two things are pretty much the same, or of regional importance. And we'll talk about a couple of emerging EPDs that are more important regionally, perhaps, than they are nationally. Those traits that are unique and novel for a reason. I've listed some of those, and as a consequence, they generally have lower data density. So, I mean, we don't have as many records, phenotypic records for them, and or they present unique modeling challenges. And by that, I mean the underlying statistical models required to generate EPDs for those traits are oftentimes more challenging. So let's begin talking about some of the more recent developments in the suite of EPDs. One is PAP, so pulmonary arterial pressure. Off the bat, I would say that PAP is not what we call an economically relevant trait, or an ERT. An ERT is something that has a direct cost associated with it, or it is a direct source of revenue. Everything else is simply an indicator trait, and some indicator traits can be quite valuable. PAP is something that for commercial entities that run cattle at relatively high altitudes, it can serve as an indicator of the risk associated with hypertension and ultimately the development of high altitude disease. Some may know it as brisket disease. And so here I just have a table. These numbers are milligrams of mercury that really give a sense of whether an animal is at low risk for developing high altitude disease, acceptable risk, or a high degree of risk. So there are a couple of genetic evaluations for PAP in existence currently. One is Angus, and really the underpinning of that is a paper that comes from Colorado State by Pauling and others in 2017, where high altitude PAP measurements, so those taken at greater than 5,500 feet at yearling time, are really the trait of interest, if you will. And then lower altitude or moderate altitude records, those taken between 4,000 and 5,500 feet, are used as a correlated trait. And the reason that's done is because, as you might suspect, as you decrease in elevation, there's more cattle in existence. And so being able to use moderate elevation records as a correlated trait really helps boost accuracy population-wide. Relatively high genetic correlation between moderate and high altitude PAP measurements, 0.8. And according to Pauling and others, at least PAP measurements taking at yearling time have a relatively low genetic correlation with growth traits. So this genetic evaluation exists. I would also mention that IGS, or International Genetic Solutions, recently completed their first genetic evaluation of PAP, and both entities, IGS and Angus, I know continue to seek data to power their respective genetic evaluations for PAP, and will continue to offer it. At least the IGS system, likely PAP EPDs won't be part of their weekly genetic evaluation. It'll be the evaluations for that will be more dispersed, simply because of when PAP data is likely to come in. I would say that if bulls are to be used themselves at high altitude, then actual phenotype here does matter, right? Because PAP provides some indicator of risk relative to developing brisket disease, which of course can be lethal. So as a consequence, if you plan on turning bulls out at really high altitude, then their PAP measurement, their actual PAP measurement is important to you. Delineate that with an EPD, which is really a predictor of how a bull's offspring will perform. In this case, what their PAP measurements may be like compared to the PAP measurements of another bull in the same breed. So if offspring are to be used at altitude, then selecting a bull based off of their PAP EPD matters. So just an important delineation here between if the bull himself is to be used at altitude or if his offspring are to be used at altitude. And of course, the bull's own PAP measurement goes into his EPD, so there is a bit of a part-whole relationship there. Right, the other relatively new trait complex would be feet and leg. And the American Angus Association also has an EPD for that. It's the actual phenotype scored on a 1 to 9 scale. So that's used for data collection. But in the genetic evaluation, only scores of 5 to 9 are actually used. 5 is considered ideal. And so truncating this actually has two advantages. One, I mentioned model complexity early on. It can be challenging when you have something that's scored from 1 to 9 and there's an intermediate optimum to actually generate an EPD that's intuitive to the masses. The other reason why they took this decision is because data density, or the number of records that actually fell below a 5, was fairly sparse. The way this works is producers score the worst foot. Part of the benefit of that is that it's a lot faster to just have to score 1 foot, whichever one is the worst. The other reason is there's at least a moderate, if not strong, genetic correlation between 1 foot being the score in 1 foot versus another foot. As you might suspect, it's important to score this prior to doing any kind of hoof trimming. That obviously introduces bias. Encourage data collection around yearling, but they do accept repeated measurements on cows. Again, I'd say foot score is not an ERT, not an economically relevant trait, but a potential, and I might emphasize potential indicator of longevity. So the interpretation of foot score EPD, if you take these two examples here, bull A and bull B, and the American Angus Association, or AGI, publish EPDs for claw set and foot angle. And breed average for both of those, I believe, is right around a 0.5. So these perhaps are more extreme examples, but on average, we'd expect that bull B should produce calves with both claw shape and foot angle that is half a score lower, which is more desirable than bull A, right? So here, if you think about the scores that are used, it scores 5 to 9. 5 is the ideal claw set, or if we're scoring foot angle, the ideal foot angle. So a lower EPD is actually more desirable. Another one is hair shedding, and similar to PAP in the sense that it's of regional importance. So hair shedding has been proposed as an indicator for heat tolerance and tolerance to fescue toxicosis. So again, it's not an ERT itself, but a potential indicator of things that may have a cost to production. It's scored on a 1 to 5 scale with target scoring dates between April and June, where might express more variation in shedding. 5 means that the animal has not shed any hair yet, all right? So they still have that really thick kind of winter coat on all the way down to a 1, which is completely shed off, so they're slick, which would be closer to ideal during that time of year. So following the scoring on a phenotypic level, lower EPD would be more desirable. Scored on cattle of at least yearling age, relatively moderately heritable, so heritability of about 0.4. And for this evaluation, they actually employ what's called a repeatability model. And what that means is that repeated observations on an individual are used. So I could score an animal at yearling time, and when that animal comes back as a 2-year-old, I could score them again, and when they come back as a 3-year-old, I could score them again. The benefit of doing that, having repeated measurements on an individual, is it does increase the accuracy of that animal's EPD over time with subsequent measurements. So that's maybe a relatively quick overview of what I would consider in the past 12 months, newer additions to the suite of EPD we already have. To some people that already maybe become a bit overwhelmed with the number of EPDs that face them when they open up a bull sale catalog or a semen catalog, talking about 3 additional EPDs probably makes you gasp. The benefit, however, of economic selection indices, which I mentioned at the top of the hour, is that they're able to combine multiple EPDs that are all important to a particular breeding objective and make selection on multiple traits simultaneously a lot less cumbersome. There are several organizations that in the past year and a half have worked to improve these tools. I would say that there are economic indices available across, I believe, all of the American breeds now, and so I point to Brangus and Brahman here, who've done so more recently. Santa Gertrudis has taken steps in the past 12 months to make improvements to their indices. And I'd just like to point out, for those that may be unaware, to my knowledge, all American breeds either currently have or are currently working to develop what I'll just broadly call fertility EPDs. So examples would be stayability or age at first calving. And I think that's really important for all breed associations to have some measures of fertility, but maybe in particular some of these American breeds. So my hat's off to those organizations. As we know, stayability or reproductive longevity, maybe is easier to think of it as, is a huge profit driver to self-replacing herds. So if you retain replacement females, there is no singular trait that's going to be more economically relevant than reproductive longevity of females. And you can think about cow depreciation cost as a reason why. The American Angus Association also did an overhaul to their suite of indexes, and although they did make changes to all of them, perhaps the most notable would be the addition of $M. So includes an expanded list of traits compared to the old $W or dollar wean calf value, and of course changed economic assumptions. In some cases, also included some non-linearity. And what I mean by that is change the assumption that as a trait continues to increase, so does its marginal contribution to net profit. So instead, for some traits, and I can think of things like milk, an example, there's a nonlinear component saying at some point, genetic level of milk no longer positively contributes to differences in net profit. You might also have heard of $C, dollar cow. That's really a linear combination between the more general purpose index, which is $M, and the completely terminal index, which is $B or dollar beef. So it's not just as simple as the sum of those two. It's really $M plus approximately 1.3 times dollar beef. It's a bit more refined than that. And so that, I believe, more broadly will be released this summer, but to those that are members of the American Angus Association, you have access to that tool now. Some of you may wonder why something like dollar beef at first blush has a greater weight in a combined index than a maternal influence index would. And that's simply a function of the proportion of animals in an enterprise that actually are terminal bound as compared to the proportion that are actually retained as replacement females. So in large part, it's a function of the number of offspring that go one way versus another. The other thing I would say that I think is a fairly substantial improvement to the indices that the American Angus Association relatively recently released, and a lot of good work by Abacus Bio in doing that, is they take into account what we call discounted gene flow. And what that means is when you keep a replacement female, she obviously has an influence on the herd over time. And so that's the discounted gene flow from the sire selection decision you made. And so that's accounted for in these indices. I'd also take a moment to mention something about data quality as I'd say an evolution, or probably an evolution of I suppose a tool that's being worked on now. Field data, I suppose, as we all know, can present challenges in terms of quality, and what I mean by field data is that's data collected by producers. It does vary in terms of quality, and although the majority of the data contributed to breed associations is of sufficient quality, meaning seed stock producers do their best to collect weights as good as they can. There is some noise because of differences in data collection effort and skill, or the methods used to collect the data. It is possible to actually categorize data based on quality to make better use of all the information that flows into genetic evaluations. And one way to do that is through the use of AI. And here, that's not artificial insemination, it's artificial intelligence. So in animal agriculture, there's utility for artificial intelligence when something comes about through a lot of different complex relationships. And that's really not the case when we're predicting EPD, and that's what I mean by additive genetic prediction. It could be more useful for phenotypic-based prediction when we're taking into account all different sources of environmental variation that manifest into a particular phenotype. But what I want to focus on just briefly is its use for assessing data quality and the quality of data entering into our genetic evaluations. So this is a slide courtesy of Bruce Golden. Bruce Golden, a colleague that has spent some time working on this, a lot of time working on this. We've spent some time here at UNL as well. And he shared some of this information at the BIF meetings just this past year in 2019. But what you'll see here is what we call a deep neural network. And not to go into a great deep amount of detail, but this input layer is information that we feed this computer algorithm to allow it then to begin to put together all the possible relationships that exist between the information that we're aware of, and it can begin to see hidden relationships amongst the data. And we go to a thing that's called the output layer, which really then provides a prediction back to us. And so the example that's of interest is something like birth weight data. So we know some people do a really good job of measuring birth weight with a digital scale. There's other people that use a hoof tape, and we know a hoof tape uses a linear circumference, or uses a circumference to predict birth weight, and as a consequence, really big calves are going to look smaller than they really are. Really little calves are going to look bigger than they really are. And what actually happens is the amount of variation due to hoof tape data is smaller than the amount of variation that we see in birth weight when somebody actually uses a digital scale. Then, of course, there's the rare occasions when somebody just actually doesn't even try to measure birth weight and just guesses or writes down weights. And so that's fake. But what we can do is utilize information we know about the data generation process, and we can use deep neural networks or artificial intelligence then to tell us, is it likely these birth weights came from a digital scale? Did they come from a hoof tape, or are they likely fake? And with that knowledge in hand, we can weight those records differently and appropriately in genetic evaluations. And so an output example would be really predictions that tell us how the generation of birth weight data came about. Was it real? Was it generated from a hoof tape? Is it fake? Or is it just messy? Did somebody just write down weights in 5-pound increments or 10-pound increments, but pretty much rank the calves correctly? Or did they actually weigh some of them and just make some of them up? So that's what I mean by messy. And if we can get these predictions, and it looks like we can, then, like I said, we can begin to appropriately use these data in genetic evaluation and give more credit, perhaps, from records that were generated under a real process, use hoof tape data appropriately, because despite the fact that most breed organizations discourage or say they will not accept data from hoof tapes, people still do it and they still turn it in. They're just not being forthright about it. And so if that's going to continue to happen, we need a way to actually flag it for what it is and use it appropriately. So that's the genesis of this. And I think it's a really neat merger of artificial intelligence, which is being used for a lot of different things in our lives, and revised genetic evaluations. Maybe as I begin to wrap up my section, some quick reminders on genomics. So I want to draw a difference between genomic selection and using genomic data at a commercial level. Genomic selection is meant to increase genetic merit in nucleus or seed stock populations. So it enhances EPDs, increases the accuracy, allows us to make faster genetic change. The DNA or marker information we use in these genetic evaluations is really conditional on the animals with records in those evaluations. So another way of saying that, when we estimate the impact of the markers, it's doing so realizing we're using that information to predict animals within that genetic evaluation or within that purebred context. When we move to using genomics at a commercial level, generally think about making selection decisions relative to replacement females. And marker effects will never be as reliable in that sense because we're using information outside of what I would call the data space, meaning we're trying to transfer information outside of the animals that were used to actually estimate those marker effects. It's something that people like Alison and I have talked about for probably well over a decade now. So I want to draw a difference between the reasonable expectations of accuracy in those two senses. I would say that commercial level genotyping represents a potential refinement after gross level genetic SOP is handled. And so that means after you have really refined sire selection decisions, which I believe is the best way for commercial people to utilize genomic information by bulls that have been genotyped, and after you have implemented a well-structured crossbreeding program. So after those two boxes are checked, then if you believe there's return on investment for using genomics at a commercial level, you can investigate that further. I think the best use of genomic data in commercial populations is enabling more commercial data capture. So being able to tie commercial animals to their seed stock relatives through the use of genomics. And this can be done by really forming genomic relationships between genotyped commercial animals and their genotyped seed stock ancestors. That's something that we're working on here at UNL, because I think that becomes the best use. Then we have commercial data flow back to our genetic evaluations, and those commercial animals, either at an individual or a group level, could receive back EPDs, if you will, that could be used for management purposes. I think that's the best model possible for the use of genomics at a commercial level. So where are we headed in the future? Published evaluations have always been in an expansion mode, and I think a reductionist approach would be wise. In example, we have calving ease EPDs. Calving ease clearly the economically relevant trait, but yet we still publish EPDs for birth weight. That's absolutely nonsensical. Birth weight's an indicator trait. It's included in the calving ease EPD prediction, so we don't need a standalone birth weight EPD. Making decisions among a growing list of partial solutions is challenging at best. So as we continue to expand the number of EPD we have, using them all to make a wise selection decision becomes more challenging. There is emerging decision support software that we're calling iGenDeck, that's under development. It's in collaboration with myself, Bob Weber at Kansas State, Bruce Golden at Theta Solutions, and colleagues at the U.S. Meat Animal Research Center, that's meant to aid in the selection process. So allows enterprise-specific selection indices, so parameterized using herd level information, would allow a crossbreed comparisons and accounts for differences between EPDs, and also includes any heterotic benefits of having chosen one breed over another, and puts it into a tool, an index that can be used to rank sires specifically for your operation. We hope to have that released in beta version this summer for a few to kick the tires on, and broader release towards the end of the year or the first part of 2021. So with that, I thank the group for the opportunity, and I'm going to now turn it over to my colleague Alison, so she can kick off her part of the presentation. Right, Alison, should be with you now.
It is. Thank you, Matt. And just give me a thumbs up that you can hear me. Josh or Matt?
Yep, I can hear you clear.
Very good. It's always nice to get that first positive feedback. So thanks so much to NCBA for inviting me, and great to hear from my colleague Matt. And I really think that these two presentations complement each other very well, because Matt kind of went through the way that the geneticists think the world should be. And then what I'm going to be doing is discussing the results from a survey that Beef magazine published earlier this year as to how this information is being used in the real world. And shockingly, they're not always exactly the same. And so I think it's always good to look at what's happening in the field and just talk about it in terms of what that means from a genetic perspective. And so I'd like to thank very much Beef magazine for sharing this data with us, and particularly Bert Rutherford. And a lot of what I'm going to be drawing on is from a piece that came out by Wes Ishmael in Beef magazine, and the hyperlink is at the bottom of this slide. But basically, this was kind of a genetics survey that was done. That was a producer survey of readers of Beef magazine, and people could opt in and fill out the survey. And the data I'll be reporting on is from approximately 650 respondents. And the breakdown of those respondents was not dissimilar to the general cattle population in the US, that a little over half were from operations with 99 or fewer cows, 36 were from operations between 100 and 500, and then about 10% were with operations from more than 500 cows. And so the first question that was asked was, how would you classify the genetic makeup of your cow herd? And we can see here that the majority answered that they had a high percentage of straight British or high percentage British, with the next most common category here being mostly British crossbred. And jointly, those two basically is what 72% of the respondents. And that certainly gels with what I see looking around the country, as there's a very high proportion of straight breeding going on. And if you break that down a little bit into who answered this particular question, I think there's some interesting numbers here. So I asked Beef to break out for me the respondents that had high percentage or straight British herds, and those that had a continental composite or a hybrid, so a Sim Angus type breakdown. And so that cut the numbers down to about 424 versus the 650 that was earlier on. But I think if we look here, you can see about 80% of these respondents are cow-calf operators. And of that high percentage of straight British, we had about 73% Angus, 9% Hereford, and 15% Red Angus. And of those that were this high percent British times continental composites, there was Sim Angus, Balancer, and Limflex. But what I think is interesting is that there was very high percentage of cow-calf operator in this breakdown, which would suggest that there's a high percentage of cow-calf operators that have a high percentage of straight British, in other words, purebred. And I think from a genetics perspective, and I guess when I look at the competing protein industries like poultry and swine, there's a very real understanding of the value of heterosis or crossbreeding, and that it should always be a consideration for commercial cow-calf producers. Obviously, purebred seedstock producers would have purebred herds if that's what they're breeding, but for the cow-calf operator, the importance of heterosis is that its greatest benefit is to reproduction and longevity. And they, as Matt mentioned earlier, is really the traits that are the main profit drivers for commercial operations. And so a general rule of thumb is to try not to have females with more than 75% of one breed. And this data really goes back a long time ago. So Cundiff had a paper in 1992 that basically reported the lifetime production of reciprocal cross and straight bred cows, and he was only looking at the so-called British breeds, the Hereford, Angus, and Shorthorn, showed a lifetime production of weight of calves weaned was about 36% increased by the effects of heterosis, and this number is even greater if it's a Taurus by Indicus crossbreeding, and that can be broken down into direct effects on crossbred calf survival and growth, and then also the effect of having that F1 female, in that there's increased maternal effects on weaning rate, the weaning rate of progeny due to the crossbred dam, and longevity of crossbred cows, and that will feed into that longevity metric that Matt was discussing earlier. And so there's quite a bit of different ways to go about crossbreeding, and I think this little chart that I pulled out of the sire selection manual, which is available on the NBCEC website if you're interested to look at them, kind of goes over some of the different breeding schemes, and I guess just really emphasizes that if you are pure breeding, that is crossing males and females of the same breed, you're effectively getting no benefit from hybrid vigor. If you cross males and females from two different breeds and create F1 progeny, you won't get any maternal hybrid vigor from a straight bred cow, but the calf themselves will have that F1 hybrid vigor. And then if you do a 3-breed cross where you've got F1 cows getting mated to a 3rd breed, maybe a terminal sire, then you'll get the full Monty, if it will. So that both the calf itself will have the heterosis and the cow will have full heterosis. This is always difficult to maintain because you have to keep those F1 cows and you have to keep a separate breed of bull, and it's not always doable for perhaps smaller breeds, and even more so if we're talking a 4-breed cross. But if I look at it, this is how the poultry industry, for example, does their broiler breeding, and they are absolutely benefiting from this maximum heterosis. But there are other approaches such as back crossing, 2 breeds rotation, or using composite or crossbred sires that gives you at least some of the benefit of heterosis. And I think, to Matt's point, to make sure you've got your SOPs in place for your sire selection is to have a consideration of, is it the right group of breeds that I'm using on my place, and am I maximizing heterosis where it's available? And if we look more generally at the past of what the producers said they've done in the last 5 years, about 18% said that they had changed the breed of bulls purchased in order to participate in a specific value-added program. And about 22 or a quarter of them changed seed stock suppliers to do so. And presumably they're working on a particular value-added program that perhaps rewards on a particular color of coat, for example. And the breed of bull that's likely to be purchased within the next 3 years is good news for Angus breeders. About 60% or 58% said that they plan to select Angus sires in the next 3 years, excuse me. And about 22% of the respondents said they plan to change the breed composition of their cow herd in the next 5 years. 54% planning to increase the percentage of British genetics, and 44% to increase the percentage of continental, and 11% to increase the percentage of Bos indicus. And so I guess the hopeful part of me hope that's being done in a way that considers the value of heterosis and crossbreeding, and it's done in a way where producers are getting the maximum value out of that. The next question that was asked was, which of the following information do you require to purchase a bull? And I've kind of marked here on the left, there's actual performance records and other documentation. On the right are things that have to do with EPDs. And so I've kind of marked up the ones where at least half of the people were looking for this information. And I think I'm happy to see that producers are doing breeding soundness examinations to make sure the bull is in fact sound and fertile and has motile sperm, and I would expect that to be a very high rating there. And that phenotype is obviously of importance because the bull himself is who you would like to see that phenotype on, because he's going to go out there and do his job. Similarly, a large number, 61%, wanted a disposition score of that animal. And again, that's an important phenotype. If you're purchasing an animal, you're looking presumably for bulls that don't want to kill you. But I think the one that worries me a little bit is looking at actual performance for phenotypes on characteristics that the bull himself has already undergone, where you're interested actually, in the case of birth weight and weaning weight, in the performance of that bull's offspring for those traits rather than his performance, because his performance is going to be influenced by things such as environment, and that is really not the concern. The concern is he going to be, for example, a bull that produces calving ease calves? And for that, we have this handy dandy EPD over here. And so if you're concerned about calving ease, then and I'm happy to see a large proportion here are saying that's a really important EPD for them. That's what you want to focus on, not the bull's own birth weight or the birth weight EPD, to echo what Matt said earlier, because it's really whether there's a calving ease issue is the problem, not necessarily the birth weight. And EPDs are the way to select for the performance of the offspring, not the actual performance of the bull. And so I think that looking at actual performance can actually distract you from the EPDs, which actually is the prediction of how well that animal's offspring are going to perform. And so I think that's a really important point to kind of keep in mind. And this one was a little bit concerning to me, in that not very many were using economic indexes. And economic indexes, I'll get into in a little bit in a couple of slides, really are a way to weight selection criteria amongst the different EPDs in an economically rational fashion, and give the appropriate weighting according to the value that those EPDs return to the property. So, do you routinely use selection indexes when identifying bull candidates for your herd? So yes was over half the people, but no was 44%. And I think it's interesting to look at of the breakdown there, and you have to go into the article to see that. So 85% of respondents were raising their own replacements, and about 18% were retaining ownership of their calves through the feedlot. And so what indexes were these producers using? 44% of the respondents said they wanted a selection index for maternal ability. And I'm a little bit unsure exactly what was meant there, because it's not maternal ability alone that you're interested in. It's presumably having a calf, getting pregnant, having longevity, but also that calf's performance and its ultimate weight and growth characteristics. And typically that's what I call a multi-purpose index, where you're interested in female traits because you want fertility, you want calving ease direct, you want all of those things, but you also want animals to grow, their offspring to grow, and so you actually want to weight a little bit for both maternal traits but also growth traits, and that's what I call a multi-purpose index, as distinct from a selection index for end product value, where you're typically selecting a terminal sire where all the offspring are going to market, none of them are being retained as replacement heifers, and that's typically called a maternal index. And basically the reason selection indexes are so important is it allows you to do a single comparison, a single dollar value between different animals, and you can weight traits according to their economic importance. So basically this A values in an index will weight the EPDs that make up that index according to the economic value of that particular EPD. And so, for example, a terminal index might put quite a high weighting on, for example, carcass weight, and it'll put effectively a 0 weighting on maternal traits because it's a terminal index. And they're designated as either terminal or general purpose, and they're easy to do comparisons because you're just looking at one particular value. And you should be aware of the EPDs that go into an index, because if the values that have gone in are traits that aren't of interest to your operation, for example, if you're a self-replacing herd and you're looking at a terminal index, you're not going to have weightings in there for important traits to do with maternal traits. And so you can use indexes in association with relevant EPDs. So maybe you're interested in an all-purpose index, but you're also, for example, interested in an animal's EPD for brisket disease that was mentioned by Matt. So you can use a selection index in tandem with those EPDs to kind of tailor it to your particular operation. And so many beef breeds now have indexes which combine the EPDs according to economics, and this is just a subset of the different indexes that are out there, and Matt mentioned some other ones available for the American breeds, Brangus, Santa Gertrudis, and Brahman earlier. And I guess I just draw kind of a general distinction between these terminal indexes, which again are when you're selecting for bulls that are going to produce all offspring going on to market. You're not interested, in this case, in the maternal end of things, as distinct from this general purpose index, which looks at really the selection criteria for a self-replacing herd. So you're keeping your females, you're keeping the who will eventually become your cows. So you're interested in fertility, size of cow herd, for example, but you're also interested ultimately in the offspring of those animals, because there will be some of those that go into the feedlot and get finished there. And this is that combined index that Matt mentioned earlier, where there's a weighting for the maternal index on this side, and then also this almost 1.3 weighting, which is basically due to the fact that all of the steers and non-replacement heifers are going to be ending up going into a terminal situation. And so making sure you use the right index is an important consideration, and it does make it easier to kind of contemplate all of the different EPDs that exist out there. And if you look at it, what our competitors are doing in terms of different protein industries, and in fact also the dairy industry, for example, has a dollar net merit that's a single index value that's used for selection on the characteristics in dairy cattle improvement. So one that's always of interest to me is, do you have a good understanding of the genomic DNA information that's being offered by seed stock suppliers? And encouragingly, more than half said yes. About 42% said no. And that actually is kind of a similar number to what was around back a decade ago, when, and I don't know if everyone remembers these days, but you had kind of a plethora of DNA information that was being presented almost in competition with the breed association EPDs. And so there were numbers of stars and profile numbers and various indexes that stood alone from EPDs. And it wasn't obvious which one you should pick. You know, should you use the EPD or should you use the gene information? And things have improved so much more since then, because it really was quite a confusing situation, to now at the breed association level, the genomic test result is now getting incorporated in, along with data on the animal's own pedigree, its own performance, and progeny information if it has it, to give you these genomically enhanced EPDs. And so you get a single value, and if you use an index, you get one single dollar value that is incorporating the genomic information as an additional piece of information, with the ultimate effect of increasing the accuracy of the EPDs, particularly on young bulls. And so one of the questions was, do you utilize genomic DNA in your bull selection decisions? And this was kind of a bit of a perplexing answer, because 46% said yes, but 54% said no. And it's a little bit unclear to me, and Wes makes this point, that this question didn't really distinguish between genomic profiles of individual animals or using DNA data in calculating genomically enhanced EPDs, because if the latter was considered, then logic suggests that this number would actually be higher, because if your seed stock producer has done a genomic test, it's already incorporated in your genomic EPD. You, as a commercial buyer, don't need to know anything about that. You just get basically improved accuracies of your EPDs. But I guess on the bright side, the idea that half the bull buyers would use genomic data in selection decisions would have been unthinkable a few years ago, in part because there was this kind of disparate way of providing that information relative to breed association EPDs. And I actually asked one of my grad students to pull a couple of bulls from her herd to kind of show how this affects EPDs. So these are both young bulls, and this particular bull has been genomically tested, and that goes into the EPDs and the accuracy down here. And so I've got an example here of a bull that has been genomically tested, and then this one here, which has not been genomically tested. And I'll just draw your attention to the yellow line here. And basically what this shows is that the accuracy of these EPDs on the genomically tested bull as you go across are all up in the 0.3s, 0.4s. That one's as low as 0.2. But if you go down to the one here that has the same phenotypic information but no genomic EPD, you see these numbers are lower in terms of accuracy, and a number of the data points are 0.05, which is basically just an index value that's an average of the two parents. And so the genomic information increases the accuracy because you're able to have a look under the hood and see which alleles that animal inherited from its parents and get a more accurate estimate of the likely genetic merit of those animals. And so that's the real value of genomics in sire selection now, is it's increasing the accuracy of those young animals. So the next question that was asked is, are you using standalone genomic tests for selecting replacement heifers? And you can see here that of the answers here, 13% of the people there said they were. And it's not clear if they were the purebred producers or the cow-calf producers. But when it says standalone, I'm assuming that means that they weren't being incorporated into the genomic EPDs of the breed association. And as Matt alluded to earlier, especially if you're testing commercial crossbreds, the marker effects will never be as reliable here as they will in a purebred population. So we know that genomic testing is more accurate if you're within breed, that those estimates were trained upon, and it gives you a more accurate estimate. And so it's about 87% of producers at the current time were not using genomic tests in selecting replacement heifers. And I thought it was interesting, the follow-up question to this was kind of intriguing, and Matt, I think, is interesting given your final slides, because it says, do you conduct a formal in-herd genetic evaluation of your commercial cows? And I have a little bit of a hard time actually believing that 17% of commercial cows are having a formal in-herd genetic evaluation done, especially if only 13% or so are doing genomic testing. And to me, this is trying to get some sort of an EPD estimate of commercial cows. And maybe, Matt, they're planning ahead for when you have your wish, and we're actually using the genomic information on commercial cattle to actually develop EPDs for commercial animals, because I think that would really be the best use of genomic information in the commercial cattle, is to actually get EPDs that are matching up their relationship with the pedigree populations that they're derived from, or their purebred sire, but also using that commercial ranch data to give them more accurate EPDs, using the genomic information to match up parentage and ultimately relationships, because it's by knowing all of those relationships that you can improve the accuracy of genomic information and EPDs. And that really, I think, is where the value comes in improving the accuracy of genetic merit estimates. And so with that, I will finish there and hand the control of the deck back to Josh to make a couple of announcements.
Thank you very much, Dr. Van Eenennaam. I kind of wonder on that last point you made there, if folks are actually keeping records of their breeding and sort of establishing their own pedigrees within a commercial herd, or keeping track of sires and dams, and that's what they mean, almost just reading between the lines there, you know, tracking their genetic makeup of the cattle. But hard to tell what they were getting at there. We're going to do question and answer here in just a moment. I do have one question already submitted. I'll just encourage you to go ahead and submit those in the chat box there if you have a question. Did want to encourage you to check out beefimprovement.org if this webinar was interesting to you and you want to dive in more deeply. There were several references to the Beef Improvement Federation conference and presentations made there in previous years, and we'll be in Orlando, Florida area this June. So we would love to see you down there and have you participate in that. The full agenda, all the registration is open, so check that out. Also, being this is an NCBA-hosted webinar platform, just wanted to inform everyone of our next big in-person event, which is our legislative conference coming up in about a month. We hope to see a lot of you there, getting involved in the political advocacy issues and understanding regulations as well, and meeting with regulators as well. And Dr. Van Eenennaam and I were having a conversation before we went live about regulation related to genetics and genomics and gene editing, and certainly has an effect on how we breed cattle in the future. So encourage everyone to get involved and advocate for progressive technology use in the future so that we have access to that. And then obviously you're on this webinar, but just a quick plug for our next series, which kicks off. We're actually going to do a webinar every week in March, 5 webinars in a row on soils, forages, and grazing management. So a little different angle with speakers from all over the country, including producers, past Environmental Stewardship Award winners. I'm really excited about this series. It'll make a great library of topics for those looking at improving their grazing, forages, grazing management, and hopefully make all of us better stewards of the land as we work to do that. So with that, we'll jump into questions. It looks like a lot of you are staying on for that, and so I again encourage you to submit those if you have any. What we have here, and I'll open this to both of our presenters, it goes back to the crossbreeding question. A producer has a predominantly Angus base. They've been using some Gelbvieh and balancer bulls over time, and they're currently AIing everything to, well, mostly to Angus with some Gelbvieh, only keeping replacements out of the AI and cleaning up with a balancer bull. And they're just, their question mainly is, are they going to lose heterosis by selecting too much Angus? And I think, you know, this was asked early on. Maybe you already answered it, Alison, with your chart. But any advice you might have for how this producer would keep some vigor in those calves through crossbreeding?
Do you want to go,
So,
Matt? Or...
yeah, I'll go ahead and jump in. Yeah, so there's going to be a loss in heterosis over time. The real critical thing for commercial cattle producers is to take advantage of maternal heterosis, so have crossbred dams. There's a huge economic impact by doing so, and so I'd encourage this producer to consider utilizing different breeds, and it could be, you know, composites, balancer was mentioned, something like that for AI, to ensure that the replacement females they keep back don't drift more and more to being straight bred.
I guess I just mentioned, if you look at that breakdown of where the benefits from heterosis are, you see a lot of the benefit is from the fertility and longevity of those F1 crossbred females.
Thank you. Another question on this, you know, similar, not exactly the same, but similar on crossbreeding. You know, what is the thought on buying in replacements that are already crossbred to sort of ease that pressure of maintaining multiple lines, and then going back with either a purebred of a different breed, a third breed, and or a composite on those? And you know, do you have any advice on selecting you know, breeders to, or know of good sources, or have ideas on getting that good base replacement female in the first place?
Yeah, so I'm not going to particularly in a recorded webinar provide names of people to source cattle from. I'll leave that up to Alison. But I would say that system, though, which is what we'd call a 3-breed terminal system, where you have you know, presumably F1 or composite dams that are either purchased off ranch or made by another enterprise on ranch, if the entire ranch is large enough, bred to a different breed of bull that's terminal. That's a 3-breed terminal, and I think that can be an extremely effective breeding system. Of course, the trick is sourcing the females, but ideally then you're taking full advantage of not only heterosis but complementarity, because you have females that should be selected based on more moderate mature size, lactation levels that fit the production environment, selected for fertility, and then you bring growth and carcass merit from the terminal sire. So I think that's great. The other caveat I would add, though, is if you're purchasing bred replacements, if possible, I'd encourage you to think about not bred heifers, but females that are bred coming with their second or maybe even third calf. That gives you even more flexibility on really pushing the envelope on growth on the terminal side, because calving ease isn't the concern that it once was. So now Alison's going to share a list of breeders.
No, I'm gonna take your sage advice on that one, Matt. Thanks all the same.
You mentioned, Alison, in your evaluation of crossbreeding, the even larger bump in heterosis if going with Bos indicus, yet there can be some environmental challenges to bringing in too much Bos indicus blood too far into the colder climate. Do you have any advice on a producer that wants to take advantage of that hybrid vigor but maybe lives where there is quite a bit of snow or some cold weather, and how to manage that, or is that just off the table for those guys?
Well, I mean, Bos indicus are obviously designed, if you will, to live in more arid, humid climates, and whilst they have great tropical adaptation in terms of tick resistance and heat resistance, they do have some drawbacks in terms of other characteristics that maybe I know, for example, that at least in Northern Australia, many of the animals don't cycle every year, and so they may not be an optimal animal for in climates where that heat adaptation isn't needed. And so I wouldn't have too much indicus up in the colder regions of the US, but obviously in the southern regions of the US, it's very useful and important. But you could have a lesser proportion of indicus. But I guess if you're up in the cold area, I would look at taking crossbreeding between animals that are well suited to that type of an environment. And when I think of cold areas, Scotland and England come to mind. And so maybe the British type breeds are probably a good crossbreeding for those types of environments.
Excellent. Well, that's all the questions I have. It looks like we're running out of questions here. So I want to thank all the attendees, thank our presenters tonight, and as always, if you need anything, if you're on this webinar, you likely have our email and contact information here at NCBA. We can certainly connect you if you have questions following up, and I think the contact information for our presenters was in their presentation as well. I'm sure they would be happy to answer questions and follow up. Hope to see you all on our upcoming webinars and in person at BIF or other meetings, and we'll see you soon. Have a great night. Thank you, everyone.
Thanks, Josh.